three involved what? Implicit differentiation, right? All three involved implicit differentiation. So with implicit differentiation, question, what do we have to remember? With implicit differentiation, what do we need to remember? Good. One thing we need to remember is the derivative of y. Whenever we're taking a derivative of an expression with y, we need y prime dy dx. And we always have to make sure that when we go to take a derivative of an implicit function, we must derive both sides. So on number 84, let me go ahead and get a blank page up really quickly because I think that's the easiest way for us to see it. Insert a page, dual page, make it big. Okay. Oh, that didn't work. That was really sad. Okay. I'm trying to make it big even though you guys have it written down. Nope, go back. Thank you. Struggle. Okay. For the first one, what rule did you guys have to use on number 84? Product rule. Yeah, that was the big one I was looking for. But yeah, we did have to think about ln, etc. So we take the derivative of both sides. And when we take the derivative, we need to think about product rule. So when you guys took the derivative, did you get second, d first, plus first, d second, equals, ooh, equals what?
0.
Ah! Did you get 0? If you put 2, I should make that a killing of a something. We haven't talked about a turtle. It has to do with not rewriting properly with negative exponents. Anyway, that's not this problem. Equals 0. And then hopefully you guys rearranged, and rearranging would have subtracted ln of y, would have divided by x, and would have multiplied by y, right? Double checking. Subtract that guy, divide that guy, multiply that guy. And that ends up matching with, I don't know, letter B looks pretty good. How about you guys? Nice. Questions on 84? Okay? 85. What's the objective? Okay, that's great and all, but translate it. What's the objective? Derivative? At 1, 1, right? So we want to find d is equal to 1 and y is equal to 1. True? Okay. So then did you guys take the derivative and get 4x cubed minus? Ooh, what did you have to do right about there? Product rule. Help me out real fast, just because I'm trying to figure out how your brains work still. Did you guys think of minus product rule, or did you bring the negative into a piece? Okay. I would have brought it into a piece. I just wanted to make sure that you guys would do the same. If you didn't, that's okay. Just make sure you put a parenthesis so you don't kill a seal. So I'm going to go ahead and do plus. Second d first. Is that an x squared? Sorry, I just covered it up. Is it x squared, negative x squared? Okay. Second d first plus first d second. You guys got your dy dx, right? And 4y cubed dy dx equals what? Good. Question. Could you work real hard to get dy dx by itself? Yeah. Did anybody think of another way of going for the answer right now without moving anything? Yeah, yours is right. You could have plugged in right away. It's up to you. You could rearrange it and make it all pretty, then plug in. Or you could plug in right away. For instance, 4x cubed is just 4, right? 1 times negative 2 times 1 is just negative 2. Negative 1 squared is just negative 1 dy dx. And then 4 times 1 is 4 dy dx. Maybe it would have made your life a little bit easier and made you getting to the solution a little bit faster. So if you're plugging in, technically you don't have to make it pretty before you plug in. You can, and maybe it's easier on your brain, and that's okay. But you could also just plug in the number as is. So 4 minus 2 is going to be 2. I have negative 1 plus 4 is going to be 3 dy dx. And so at the end of the day, after I subtract 2 and divide by 3, I end up with, oh my goodness, another b. You guys agree? Go team. Questions? Could you have gotten dy dx by itself? Yeah, I don't want to negate your work, and I don't want to disqualify what you did. You totally could have. I just chose to be lazy and not isolate dy dx first. Okay, number 86, what's the objective? Second derivative. But do you guys notice how, at least sometimes when they ask for a second derivative, it's kind of an easy guy? Do you see that? Makes it a little bit nicer. If I do d dx sides, hopefully you guys got x equals what? Careful. The better you get, the faster you go, the quicker you can make little baby mistakes. So that leads us to dy dx is equal to, check me, is it negative x over y? The 2's reduced. Not good enough though. Oh, plug in! No, if you plug in, it's a number, it's a constant. And the derivative of any constant is 0. We have to keep it variable, have to keep it changing. All right, take another derivative. So the derivative of dy dx is d squared y over dx squared equals, you did quotient rule, right? Bottom d top minus quotient rule. Top d bottom all over bottom squared. Do I have to make this pretty? Not technically. What am I doing? Plugging in, plugging in. But what do I need to at least kind of consider? Dy dx. So I'm going to rewrite it just a little bit because I need to get that dy dx in. But once I have the dy dx in, I can go ahead and technically it'd be illegal to say equals and then put in numbers. But I could go ahead and do like a little such that, and then I could say equals, or I can just do some sort of like this implies arrow at the point 6,8 d squared y over dx squared is equal to, plugging in 8, negative 8, plugging in 6, that'd be 36, plugging in 8 and 6, or I should say 6 and 8, and then plugging in 8, that's 64. That's 3/4, right? 3/4, and then 4 into 36 is 9, so 9 and 3 is 27. So I'd have negative 8 minus 27 all over 64. Right away, we could just say, hey, we have negative numbers, so let's forget both of those. Does that not simplify? Was I being silly? 6 squared is 36. Is it not reduced? Yeah, what did I do wrong? Oh, thanks. That's why it's weird. Thanks, Christina. I have no idea. I don't know why I put a squared. Oh, I think I saw these two, and I just put a squared instead of keeping it unsimplified. So that should just be a plus 6. That makes more sense. Okay. Because then that doesn't reduce. We could go ahead and it reduces a little bit. I can make that a 3. I can make that a 4. So then I have negative 18. So negative 8 minus 18 all over 4 all over 64. I could make a quick little simplifying a complex fraction. So when I distribute, you're in my way. When I distribute, that's going to be negative 32. That, the 4 just cancels, so I have negative 18 all over, I'm guessing that's 120, 64 and 4? Oh, something must reduce, because that's going to be 246. Cut in half is 128. Oh, so that must be an even. Negative 50 over 246, which is going to end up reducing to negative 25 over 128. Dun, 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 dun. We got an A. Haha. BBA, who got all 3? Ooh, who got at least 2? Who got at least 1? You guys are silly, because at least means the people who got 3 and 2 should have also raised their hands. Anyway, go team. We're in math, it's okay. Any quick questions before we move off the screen, off 85, 86, 84? I know that was out of order, I apologize. All right, let's go grade our homework and see where we got stuck. Let's go grade our homework and see where we got stuck. We do need to get into section 2.6, but let's grade fast. In a way that is complete, in a way that is helpful. What page was homework on, guys? Perfect. It's faster than me flipping there. All right, I have it up and ready if we need it. And then here are our answers for the evens. Number 4. Make it match. Remember, you might have the evens written differently. So I'm going to take just a little bit longer on each question. You might have them written differently. Make it match. If you have something different written down, if I were you, I would write down the final answer real quick in a colored pen. And then, if you don't have time in class, go back and see, does it match, does it not? Maybe you'll have time to figure it out in class. Maybe you won't. But get down the back of the book answer that you eventually want to make sure you can make match. So the first one, negative 2x squared over 3y squared, is the fully simplified form. Next one, number 10. Negative, careful, it's a negative. Negative y times e to the xy plus 2x all over x times e to the xy minus 2y. But not as bad.
Yeah, well, sometimes it is.
Oh, well, that's true.
Certain times of the day, it's like, like there's probably 30 lockers of stuff all on the floor. It's like,
food all squished into the. It's hilarious. Did you guys hear Mrs. Christensen? Oh, that's funny. That was when they first put it in. Have you guys already gotten number 18? Whoa, that's awkward. That's weird. I like that, but can you make it match? Written a negative y minus a 5xy up out of the parentheses. They all mean the same thing. They're just saying the whole thing's negative. Okay. But they got a common denominator, in case you're wondering how to make it match. I don't think it's mine. I think I turned my sound off. Number 22. Maybe I didn't. Or it could be my iPad. Sorry. Didn't think about that. Off of my iPad. All better. It's a negative. There's so many negative answers. Don't be negative people. Negative y over e to the y plus x. Number 28, you guys can see that you're supposed to be plugging in. If you got the 1/3 off or wrong, check your derivative. 2x over 3y squared. Number 54 was a second derivative. Huh? 28's right here. Y prime and then 1/3. Number 54. They say y prime, you would have said probably dy dx. They were kind of weird in how they did it. They actually didn't take the derivative with quotient rule. They came back here and used product rule. So they did second d first, y prime times 3y squared plus first d second, 3y squared times y double prime. It's not that it's wrong, it's just kind of awkward, and there's a lot of stuff to keep track of. I would rather do a quotient rule, have a dy dx, plug it in, and eventually you're supposed to be plugging in a number? Oh, no. No number. Never mind. No number. What they show at the very bottom is that you could have done this another way. You could have cubed rooted both sides. That's all this note says. You could have cubed rooted and then done a quick little chain rule for the first and second derivative and gotten there a lot quicker. The awkward part would have been to make it match. You would have had to take this guy and go back and been like, oh, hey, it's this guy to the 5th power and plugged in y. So the making it match would have been hard. The deriving would have been easy if you had gotten y by itself, as long as you didn't kill bunnies. But making it match might have been hard. 66. Oh, yuck. Oh, LNs. Didn't LNs make everything better? Because if you do ln, you can have ln of that guy plus ln of that guy minus ln of that guy minus ln of that guy. Their derivatives are nice and neat. Multiply by y. Plug in what y is. Ew. What did they do from here to here to here? How'd they get all of these mushed together into one? Starts with a C and ends with the common denominator. Thank you. They would have had to get common denominators, and that's what was going on here and here. They said, oh, hey, that's x squared minus 4. Let's multiply each of those by the other guy. That's x squared minus 1 as a common denominator. Let's multiply those by the other guy. So there's a lot of math that was going on in between these huge old jumps, but all they did basically was a common denominator and then put it all together. Whew. So I would write down this final one and then see if you can make it match. Because to be honest, their steps don't even really show like the math that went into doing it. It was all common denominators. Guys, was there any other way to solve or find this derivative besides ln? There's no other legal way. X to the n fails. That's not a constant. B to the u fails. That's not a constant. The only way is with an ln, bringing that guy down, and a product rule. Second d first plus first d second. Move the y to the other side. Plug it in, and look, they leave it. They don't even worry about common denominator mess. They don't even worry about common denominator mess. Number 72, the exact same thing. The only legal way is to take ln of both sides. Bring down the power, which was an ln. I know it's gross, but it's true. Product rule. Second d first plus first d second. Multiply the y. Plug in. And simplify. Plug in and simplify. That sounds a little bit easier than it really is. But if you guys notice, there was some simplifying that occurs as far as you just get a 1 over x. And this guy, also 1 over x. They pulled the 1 over x out. Then they multiplied the y and then plugged in. They rewrote it kind of weird because they put everybody over x over here and the y over there. But either way, that's your final answer. Do we have one more? You guys can see him right up there. A, all they were asking for is that the slope is higher or greater, aka steeper. Letter B, there are vertical tangent lines about negative 2, 3, and 2, 3, and then a horizontal line about 0, 6. There's a leveling off, is letter C, and straight for letter B. I think that's the last one. Okay, I have the book ready. What we need to talk about, and but I can do a couple. Evens. What else, AJ? Okay, let's start there, because they're both odds that you could have checked, and we still have questions on. 25 and 67, and then if we have time, I'll take one more. So number 25, what were the directions as we go there? Okay. Nice thing is, this is a pink one, so there was a video going along with it. I think that's why I gave you, even though the directions were kind of crazy, I gave you that one. But let's check the directions real fast. 2 explicit functions by solving for y. Sketch the graph, label the parts given by the corresponding explicit, differentiate the explicit, and then go implicitly and show that they're the same thing. So basically it's saying like, hey, old school, get y by itself. Figure out what kind of function this is, and derive it with y by itself, and then come back and say like, well, what if I had just done it implicitly and derive it and be like, can I figure out that they're the same thing? Can I make it match either way? So then this guy, to get y by itself, don't we have to subtract? No, add and plus or minus square root some stuff. So if we were to take this guy off to the side and make him explicit, I would have to get y by itself, which means I would have had to add add the x squared. Divide the 16, which is good and all, but when I square root a squared, I get plus or minus square root. I'm going to do the heart method where I divide top and bottom by 16 to make it look a little prettier, because 16 over 16 is 1. And then that's going to be 1/16 x squared. Just a few of you might have wanted to square root, but that'd be killing a puppy. If I tried to find the zeros or the factors of that, they're imaginary anyway, but they also don't match. They're not squared. So why did they say the explicit functions? Because there are 2 of them. Y squared fails the vertical line test. This is not a function. But 2 functions could go together to make him. So if you had graphed this guy, you guys aren't going to like it. Last year we would have said divide everything by 16. And you would have had y squared over 1 minus x squared over 16 equals 1. And then we would have talked about how this is actually the graph of hyperbolas that are oriented in the pre-cal y direction, with the center at 0, 0, and going up in the, let's see, up and down, going up 1, down 1, over 1, 2, 3, 4, 1, 2, 3, 4. That would have been our little box. That would have made our asymptote slopes. Then our asymptote slopes. Then we would have come up here to make our vertices. And swoop, there it is, swoop, there it is, swoop, there it is, swoop, there it is. That's pre-cal. Go team. But you could have put in the positive square root to your calculator. That's what they were indicating. And the negative square root to your calculator. Who's who? Well, this guy's the positive root, and this guy's the negative root. So far, I think we've done A and B, and we still need to differentiate those guys. If you differentiate, if you guys notice, plus or minus, our dy dx is actually just going to be a plus or minus 2. But we're going to have to bring down the 1/2, make this a, which is going to be 1/8 x. Okay, those are the slopes. But then it says, remember how we're learning how to do implicit? We're basically saying that none of that was truly necessary. Unless you're really good at pre-cal, you could have gotten the graph a lot easier by getting, well, even then, we wouldn't have gotten y by itself. We would have thought about the hyperbola standard form. Why not just derive it implicitly? And life is so much better. Which one looks nicer? That one. But how could I make them match? Who do I have chillin'? That's not in the other answer? And what could I plug in for y? Now, would it have taken a little bit of by-hand simplifying action to make it look like this? Oh, actually, hold on. A square root in the denominator, a negative 1/2 power, with 2 times 8 is 16 on the bottom and x on the top and a plus or minus. They're the exact same thing. They're the exact same thing. But to make them match, you would have had to take the implicit derivative and make it explicit by plugging in what y truly equaled. Patricia, that good? Cool. And then AJ, you said 67? Okay. Number 67. Kappa curve, cruciform. What? They're these special math graphs we've never seen before, or never knew there was a special name for. Logarithmic differentiation. Is there any other way to solve for this guy's derivative? Nope. Completely illegal. Any other way. No matter what your brain says. Power rule, illegal. Bulimbu, illegal. So what do we have to do to both sides? Did you guys get this down last night? That comes down in front, and now we have a product rule. Because we need to take d dx at both sides. Do I have a blue? I do have a blue. AJ, good so far? Cool. We'll take the derivative, 1 over y dy dx equals, second. Don't kill a turtle. Ha ha, I get to introduce it. Okay. How do you take this derivative? Box prime. You could do bottom d top minus top d bottom. Bottom d top, derivative of 2 is 0 minus top d bottom, that's 1 all over bottom squared, which ends up being negative 2 over x squared. Was there any other way? Anyway, do both work? Yes, you could have done quotient rule. Remember I told you once you learn quotient rule, you're going to use it more than you need to? It's okay, it works. But so does this. But you have to be careful. When you rewrite, anything in the denominator becomes a negative power. Then we go ahead and we can rewrite again. Long story short, sorry, that was box prime. plus first d second. Oh, that's nice. They get common denominators. Go team. So I end up with negative 2 ln of x plus 2 all over x squared, because he has an x squared and he has an x squared. I need to multiply both sides by y in order to get dy dx alone. Which, AJ, you could have gone looking in the back at that point, but I bet they would have gotten rid of this guy. Why? Who was he? So we plug in our x to the 2 over x, who is y, times, I guess we could pull out a negative 2 also if we wanted to. And that would be ln of x minus 1 all over x squared. Now pause. I don't have the answer to make it match. AJ, how close am I? Okay. The original function, sorry, it gets kind of messy when I start writing. The original function was x to the 2 over x. So he was the guy that I plugged in for my y. Does that make sense? Yeah, sorry, he got a little messy up there.
Oh, wait, because they brought up the x squared at the bottom.
Oh, they combine like terms. Okay, thanks. What AJ was saying is that they actually rewrote this. So they're like, hey, that's x to the power of, that's x to the power of. Exponent properties say that division of like bases is subtraction of the powers. So 2 over x minus 2. And they like that a little better because then the division is gone. I mean, it's messy, but yeah, make it match. Like bases, I can subtract their powers. Good. Is this making you guys get better and better at exponents? Yeah. Sorry, I can't take more questions than that, but hey, if you need a stamp, come on in and ask another homework question, and I can walk you through it if for any reason you were confused. The evens, if you're like, I'm not sure I can make it match, take some time with it this weekend. Because maybe you wrote down the answers, but you're not sure about the making it match part. Take some time, now that you know what they are, see if you can make them match. And let's go back to section 2.6 that we barely started yesterday. We only talked about pre-cal. Inverses, reflections across y equals x, like e to the x, swoop, there it is, and ln, swoop, there it is, right? Or square root of x and x squared. Or x cubed and the cubed root of x. All of these are inverses, reflections across the y equals x line. We set the x and y and solve for y. We have the f inverse notation. Uh-oh. I'm still a little scared about you guys with this notation. So I'm going to write f inverse of x as a reminder. Whenever you compose an original with its inverse or an inverse with its original, plugging one into the x's of the other, they are each other's undoing. Oh, there's some life lessons there. But anyway, be careful. Be nice to everyone, but choose your close friends wisely. Anyway, inverse functions, they are each other's undoings, aka if you compose one with the other, everything, the addition, the subtraction, the multiplication, the powers, the logarithms, everything cancels out down to x. The domains and ranges switch, the x's and y's switch. That's all pre-cal. Don't worry, I'm coming back. Speaking of pre-cal, a couple more pre-cal, and then we start to get into the calculus with continuous and differentiable. A function has an inverse, that's a function, if it passes the horizontal line test. Another way of noticing that, and I'm going to just actually put example. If you get y by itself, and if y equals, say, a plus or minus of anything, usually it's going to be a square root of something like 4 minus x squared. That's a good example. If y equals plus or minus, that means two functions need to combine to make another expression. Those ones are always going to fail. Can I put it that way? Bless you. It's like the one we just did with the hyperbola. Since we got y by itself and we had a plus or minus, it took two functions to make the original function. That would be an example, like algebraically, of one that failed the horizontal line test. AKA its function, its inverse will not be a function. If you guys remember from last year, we called those ones that pass HLT one-to-one or invertible. Maybe some of you guys are having flashbacks to the one-to-one property with logarithms and exponentials, since logs and exponentials always pass the horizontal line test. We can make one side match the other side as far as the base or the log base. We can just ignore them and set the arguments equal to each other. Sorry, that's off the top of my head because we're doing it in honors right now. Honors pre-cal. But the function's one-to-one. It has some pretty big implications as far as solving, but not so much for us this year. If a function has an inverse function, if a function has an inverse function, if f is continuous, guess what? F inverse is continuous. Here's the struggle though. If f is continuous on an interval AB, f inverse is continuous on the interval f of A, f of B, because the x's of the original are the y's of the inverse. Or I should say the y's of the original are the x's of the inverse. So that gets a little bit confusing because it might be on different intervals. If f is increasing, like exponential, like e to the x, if one is increasing, the other is increasing, but at different rates. If f is decreasing, f inverse is decreasing, but at different rates, different slopes. If differentiable, if f is differentiable at x equals c, such that f prime of c equals, how do I want to put this? A. Differentiable means the derivative is this. Then f inverse is differentiable at x equals f of c. Remember, the x of the original is not the x of the inverse. So the x of the original, the y of the original, f of c, is going to be the x of the inverse. Such that, here's where it gets funny. F inverse prime of f of c equals 1 over a. Ugh. And this is where it starts to get a little confusing. Some of you would say you were confused when I said the word inverse, but more than that. I'm actually not going to do this graph here. Instead, I'm going to go over to this side. I don't think I have any words up there, do I? Oh, I do have words. I'm going to use a super basic example, okay? Let me do y equals x cubed, or f of x equals x cubed. And then let's do, you guys can see the reflection across y equals x. F inverse of x, you guys know hopefully is the cubed root of x. If we were to switch x and y, solve for y. The dealio is, if I was to ask you guys to find the derivative at bummer. We'll come back to this. That's all right. Here's a dealio. It would probably be a really smart idea as far as preparing for next week. It'd probably be a really smart idea to go find like a CalcAB video on derivatives of inverses just to watch just a little bit of it. Maybe you could start your homework, maybe you couldn't. There is a rule, it just gets confusing. So I don't think homework is super long for Tuesday, but you might want to get a one-up on that. But definitely make sure you go through anything you missed on section 2.5 to make it match, all right, guys?